Hello students, in my previous video on this chapter pair of linear equations in two variables, I have explained you how to draw a graph. Now today I am going to show the behavior of lines representing pair of equations. So let me first explain the basics, then I am going to do sums of exercise 3b. Now suppose we are having two equations. Equation number 1 is a1x plus b1y plus c1 equals to 0, and second equation is suppose a2x plus b2y plus c2 equals to 0. We know since these are linear equations, as already I have explained in my previous video why they are called linear equations. Now in these linear equations, if I plot, then I am going to get a straight line. Now the question is, when two equations are there, by seeing the equations, how can we check whether they are going to intersect at a point or not? When we plot this type of two equations, we may get two lines which cut each other at a single point. There may be lines which are parallel. There may be a situation where lines are coincident. Now how to check? It is not always possible to draw the lines and to check whether they will intersect at a point or not. So in this lecture, I am going to show you the tricks by which you can check whether they are going to intersect at a point or not by comparison of ratios. Now let me explain the process. Suppose we are having this type of two equations and we want to check whether the lines will intersect at a point or not. For this, we have to check this. a1 by a2 should not be equal to b1 by b2. If a1 by a2 and b1 by b2 are not equal, then you are going to get this type of situation where lines will intersect at a point. So if a1 by a2 is not equal to b1 by b2, that means lines are going to intersect. That means intersecting lines. And since they are going to meet at a point, so it will have unique solution. Unique solution means exactly one solution. Unique solution, or you can say exactly one solution. And since we are going to get at least one solution, we use the term consistent. Clear? So that means by seeing this condition only, we can conclude these three. Now let me explain the second case. Case 2. In case 2, we can say if a1 by a2 equals to b1 by b2 equals to c1 by c2. That means ratio of a1 by a2 equals to b1 by b2 equals to c1 by c2. If this is the case, then you are going to get coincident lines. Coincident lines. That means here situation is something like this. Suppose this is one line, second line will be here on top of it. They are called coincident lines. And here all the points are the solution. That means there are infinitely many solutions. We can write infinitely many solutions. Clear? And here also, since we are going to get at least one solution, we will say these are consistent, though it is dependent. And in case 3 I can write, suppose a1 by a2 equals to b1 by b2 not equals to c1 by c2. If this is the case, a1 by a2 equals to b1 by b2 not equals to c1 by c2, then we are going to get a situation where lines will be parallel to each other. And when lines are parallel to each other, they are not going to meet. And since they are not going to meet, there will not be any solution. So you just write here parallel lines. Parallel lines. And we know parallel lines are not going to meet each other. So we can write here no solution. No solution. And these are called inconsistent because we are not going to get even a single solution. So these three rules you have to remember. I hope these three conditions are now clear. And based on this, now I am going to show sums of 3b. In exercise 3b, question number 1, which of the following pair of linear equations has unique solution, no solution, or infinitely many solutions? And these are the two equations. The equations are 2x plus 5y equal to 17 and 5x plus 3y equal to 14, and we are to check whether they have unique solution, no solution, or infinitely many solutions. For this, what we have done, we have shifted 17 and 14 in the other side, so we got 2x plus 5y minus 17 equals to 0. Let it be equation number 3, and 5x plus 3y minus 14 equals to 0. This is our equation 3, this is equation 4. Here we are comparing first equation with a1x plus b1y plus c1 equals to 0. So a1 will be 2, b1 will be 5, and c1 will be minus 17. And if I compare this equation with a2x plus b2y plus c2 equals to 0, then I am going to get a2 equals to 5, b2 equals to 3, and c2 equals to minus 14. So in this way we got a1, a2, b1, b2, c1, c2. Now you just take the ratio of a1 by a2, you calculate this, you are going to get 2 by 5. If I calculate b1 by b2, I am going to get 5 by 3, and c1 by c2, c1 by c2 will be minus 17 by minus 14. On cancellation of negative sign, I am going to get 17 by 14. Once you have calculated these three, now clearly you can see a1 by a2 and b1 by b2, these two are not equal. So since a1 by a2 not equals to b1 by b2, therefore, and this is a condition for unique solution, therefore given pair of equations, you can write linear equations also, have unique solution. In question number 2, first part, find the value of k for which the following system of linear equations has no solution, and these are the equations. Okay, let me show how to do this sum. Here equations are kx plus 2y equals to 5, 3x minus 4y equals to 10. If I transfer this 5 and 10 in the other side, I am going to get equation number 3 and equation number 4. Now in the question it is given, you are to find the value of k for which the system of equations has no solution. So here a1 is how much? a1 is k. b1 is how much? b1 equals to 2, and c1 equals to minus 5. a2 will be how much? a2 will be 3, b2 equals to minus 4, and c2 equals to minus 10. And since here equations has no solution, for no solution what's the condition? I told you little while ago, for no solution, condition is a1 by a2 equals to b1 by b2 not equals to c1 by c2. This is the condition. Now what is a1 by a2? It is k by 3 equals to 2 by minus 4 not equals to minus 5 by minus 10. Now if I consider first two part, from first two parts I can write k by 3 equals to 2 by minus 4. So I can write minus here, minus 2 by 4. So if I cancel 2 1 ja 2, 2 2 ja 4. So k equals to minus 3, 3 1 ja 3, minus 3 by 2. From last two part, if I take this part and this part, from last two, there is no value of k. There is no value of k. Therefore, we can write, since from first two, from this part, we got k equal to minus 3 by 2. And in the last two parts, as you can see, no k is there. Therefore, k equals to minus 3 by 2 is the required answer. In question number 3, first part you can see, find the value of k for which the following system of linear equations have infinite number of solutions. So this is our equation number 1 and this is equation number 2. Already it is given that they have infinite number of solutions and we are to find the value of k. So let me solve this sum. Now here equations are 2x plus 3y equal to 7. I have transferred this 7 in the other side. We got this equation. And here this 3k I have transferred in the other side. I got this. Let it be equation number 3 and 4. A1 will be 2. B1 equals to 3. And C1 equals to minus 7. And here A2 equals to k minus 1. B2 equals to k plus 2. And C2 equals to minus 3k. And in the question it is given infinite number of solutions. So you can write here for infinite number of solutions. For infinite number of solutions, condition is A1 by A2 equals to B1 by B2 equals to C1 by C2. So if I consider first here A1 is 2, so 2 divided by k minus 1 equals to 3 divided by k plus 2 equals to minus 7 divided by minus 3k. Now this minus we can cancel. So if I take first two part from first 2 by k minus 1 equal to 3 by k plus 2. If I cross multiply, I am going to get 2k plus 2 equals to 3k minus 1. 2 into k, twice k, 2 2 ja 4 equals to 3k minus 3 1 ja 3. So twice k minus 3k equals to minus 3 minus 4. So here minus k equals to minus 7. Therefore k equals to 7. From first 2 we got the value of k is 7. Let me check from the last 2. From last 2, 3 by k plus 2 equals to 7 by 3k. So if I cross multiply, I am going to get 3 3 ja 9k, 7 into k, 7k plus 7 2 ja 14. So 9k minus 7k equals to 14. 9 minus 7, 2k equals to 14. So k equals to 14 by 2 equal to 7. So in both the cases, in the first case also we got k equal to 7. Now also we got k equal to 7. Therefore required value of k equals to 7. That's your answer. Let me do number 4. Determine the value of k for each of the following system of linear equations have unique solution. It is given unique solution. These are the equations and we have to find the value of k. So let me solve this sum. This type of sums are very important for exam purpose. Here from the equations we can write A1 is 2, B1 is 3, C1 is minus 5. Since already in the right hand side it is 0, so no need to transfer. So A1, B1, C1 we got, and here A2, K, B2 minus 6 and C2 is minus 8. And since in the question it is given unique solution, we can write for unique solution. For unique solution, what is the condition? For unique solution, A1 by A2 not equals to B1 by B2. What is A1? 2 by K not equals to 3 by minus 6. So 2 by K not equals to 3 and 6 can be cancelled. We got 1 by 2 because 3 2 ja 6. So if I cross multiply, I am going to get k into 1, k not equals to 2 2 ja 4. That means k not equals to minus 4. Therefore, for all real values of k, except minus 4, the given equations will have unique solution. So what's the answer? It can be anything, any real value of k is the answer other than minus 4. In question number 5, given below are 3 equations. 2 of them have infinite solutions and 2 have unique solution. State the 2 pairs. So 3 equations are there. From these equations we have to find 2 equations which will give infinite solution, and we have to find another pair which are having unique solution. So here this is the first equation, second equation, third equation. First equation can be written as 3x minus 2y minus 4 equals to 0. Second one is 9x minus 6y minus 12 equals to 0. And third one is 6x plus 2y minus 4 equals to 0. Now if I see first equation and second equation, 3 by 9, that means a1 by a2. Just check mentally because this type of questions often come for 1 mark. So 3 by 9 will be, so if I see first and second equation, 3 by 9 will be 1 by 3. That means a1 by a2 will be 1 by 3. What is b1 by b2? b1 by b2 equals to minus 2 by minus 6. Minus 2 by minus 6. If I cancel, I am going to get 1 by 3. And c1 by c2 also, minus 4 by minus 12. That will be 1 by 3. Since all these 3 are equal, therefore, it will give you infinite number of solution. Infinite number of solution. Now, if I consider first one and third one, a1 by a2, if I consider these two, 3 by 6, 3 by 6, if I cancel, I am going to get 1 by 2. If I consider b1 by b2, it will be minus 2 by plus 2, it will be minus 1. So they are not equal. No need to check c1 by c2 because a1 by a2 is half, b1 by b2 is minus 1. They are not equal, and we know when they are not equal. Therefore, you can write here, since a1 by a2 not equals to b1 by b2, therefore this will give you unique solution. And in this case, since a1 by a2 equals to b1 by b2 equals to c1 by c2, therefore it will have infinite number of solution. So first one and second one, if you consider, they are going to give infinite number of solution, and first and third, if I consider, I am going to get unique solution. In question number 6, we are to prove graphically, and in my previous video already I have shown you how to plot graphs and to check whether they are consistent or not. So I am not doing this sum. Now let me do question number 7. Find the condition for the following system of linear equations will have unique solution. These are the two equations, and we are to find the condition for which they will have unique solution. Let me solve this sum. Here ax plus by equal to c and lx plus my equal to n. Let it be equation number 1, and this one is equation number 2. Here a1 is a, b1 is b, and a2 is l, and b2 is m. And for unique solution, we know the condition is, for unique solution, we can write a1 by a2 not equals to b1 by b2. Since c1 by c2 is not required, so I have not written. Now what is a1? a1 is a, a2 is l, b2 is b by m. So if I cross multiply, I am going to get am not equals to bl. Further simplification is not possible. So this is the condition by which we can say that lines will have unique solution. Now in question number 8, for what value of k, the following system of equations will represent the coincident lines, and these are the equations. Here we can write a1 is 1 because coefficient of x is 1, b1 equals to 2, and c1 equals to 7. And here a2 equals to 2, b2 equals to k, and c2 equals to 14. So we got a1, b1, c1, a2, b2, c2. And since coincident lines, these are the lines, suppose, and we know the condition for coincident line is a1 by a2 equals to b1 by b2 equal to c1 by c2. So we can write 1 by 2 equals to 2 by k equals to 7 by 14. Now 7 and 14, if I cancel, I am going to get half. So we are left with half equals to 2 by k. Cross multiply, k into 1k, 2 to the 4. Therefore, required value of k is, required value of k equals to 4. In question number 9, you are to find the value of a and b so that the following system of linear equations have infinitely many solutions. So two equations are there, and we are to find the value of a and b. In question number 9, these are the equations, and we can consider this one is a1, b1, c1, a2, b2, c2. Now for infinite number of solution, for infinite number of solutions, we know the condition is a1 by a2 equals to b1 by b2 equals to c1 by c2. This condition is known to you. Now a1 is twice a minus 1 by 3 equals to 3 by b minus 1 equals to minus 5 by minus 2. Minus minus can be cancelled. Now, if I pair this one and this one, first and last, I am going to get twice a minus 1 by 3 equals to 5 by 2. If I cross multiply, 2 2 ja 4a minus 2 1 ja 2 equal to 3 5 ja 15. So 4a equals to 15 plus 2. So 4a equals to 17. A equals to 17 divided by 4. We got the value of a from first and last. Now, if I consider second and third, 3 by b minus 1 equals to 5 by 2. If I cross multiply, 5 into b, 5b, 5 1 ja 5, 3 2 ja 6. Now, 5b equal to 6 plus 5, 5b, 6 plus 5, 11. So, b equals to 11 divided by 5. Therefore, required value of a is 17 by 4 and b is 11 by 5. In my previous video, I have shown how to solve graphically. So, this type of equations now you can do yourself. That's all for today. In my next video, I am going to show sums of 3C. Till then, bye bye, take care and wait for the next video.